In this video, we're going to continue talking about sampling and surveys. So in our last video, we talked about something called an SRS, which is a simple random sample, and that's when you use a random number generator to assign numbers to a sample in a larger population to survey that group. Hopefully, they represent the overall population of that survey or whatever it is that you're trying to find. Another SRS, so great, we're using the same acronym, not confusing whatsoever. It's called stratified random sample. Now, what's a strata? Let me tell you. Strata are groups of individuals in a population who share characteristics thought to be associated with the variables being measured in a study. So, stratified random sampling takes an SRS, or a random number generator, assigning random numbers, just like the simple random sampling. And it's going to choose a sample using that SRS from each stratum and combining those random numbers into one overall sample. So essentially you're taking a bunch of different little stratums, so little groups, and you're sampling from each of those, hoping to get a broad scope of whatever it is that you're asking them, whatever it is that you're surveying them. So, for example, let's say that the entire survey population is the entire high school, students in a high school. So you can divide that population, depending again on how you're surveying or what you're asking, into different strata. So you could split them up by grade, 9th, 10th, 11th, and 12th graders, or other types of groups. A note about stratified random sampling is that it works best when the individual in each group, so for example 9, 10, 11, 12, are similar in respect to what is being measured. So maybe it's about hours of homework, or their sleep habits, or the amount of extracurriculars they do. They're related, but there's going to be some difference, because I don't think I need to convince you that 9th and 12th graders are different in a lot of different ways, but similar enough that you could still include them in the same survey. Now, sometimes SRSs, simple random sampling, or stratified random sampling, are harder to use because populations can be really large and spread out over a wide area. Something that would help in that situation is to use what we call cluster sampling. So that's when individuals in a population are quote unquote near each other. So that's the idea of cluster sampling, right? They cluster together. So what is a cluster in terms of cluster sampling? Now that's a group of individuals in the population that are located near each other. So distance is key here. They're close to each other. So cluster sampling selects a sample by randomly choosing clusters and including each member of the selected cluster in the sample. So what does that mean in an example? So again, let's say that our population is all of a high school student body, and let's say that those students are divided alphabetically into homerooms or advisory groups. So if it's by alphabet, that means that you could have 9th, 10th, 11th, and 12th graders in the same homeroom or advisory, because just based on their last name. So let's say that admin wants to survey students about a proposed schedule change, and instead of surveying all of that high school body to get their response, they decide to select a small cluster sample of homerooms or advisory groups using a random number generator. So they would have to select enough to represent that entire student body, but they're doing it using cluster sampling. So although a stratified random sample and cluster samples are similar, at least on paper, they are a little bit different. So we want all of our stratums, so multiples of strata, to contain similar individuals in that population, but we want large differences to exist between those populations. So think about, the difference between like 9th and 12th graders. In clusters, we would love for each cluster to look like the population, but with a smaller scale, so we don't have to do a survey. Cluster sampling is often used when you just want a quick survey. It's usually for practical reasons like saving time or money. So cluster samples don't always offer the statistical advantage of the better information about a population that using strata would give you. So let's take a look at an example. Surprise, surprise, this one has to do about schools and is school population. So let's sample at a school assembly. The student council wants to conduct a survey about the use of the school library. What's that? During the first 5 minutes of an all-school assembly in the auditorium. There are 800 students present at the assembly, and here's a map of the auditorium. So note that students are seated by grade level and that the seats are numbered from 1 to 800. So 9th graders are 600 to 800, 10th are 400 to 600, 11 are 200 to 400, and the 12th graders are 1 to 200. And of course, here's how they're seated. So 1 all the way through 20, 21 through 40, etc., all the way up to 800. All right, let's do 2 things with this data. First, let's describe how to obtain a sample of 80 students using stratified random sampling. And let's explain our choice of strata and why this method might be preferred to simple random sampling. So really we're trying to get at the idea of the difference between simple random sampling and stratified random sampling. One way to think about answering this question is students' library use might be similar within a grade level. So, for example, amongst 9th graders, they might all have similar library use, but it's likely to be different across grade levels. So compare that 9th grade library use to junior or senior library use. Similar enough, but different. So hopefully you get a variety of responses from your survey. So what you could do is you could use those 4 grade levels, 9, 10, 11, and 12. And if we're looking for 80 responses, 80 divided by 4 is 20. So what you would do is you would generate 20 random integers for each of the grade levels and their seat numbers. So for 9th grade, we'd generate 20 random integers between 601 and 800. For 10th grade, 20 random integers between 401 and 600, etc. And we would ask those students sitting in those random seats, those 80 random seats, to take the survey. And so that is how we would use stratified random sampling. And it should result in a more precise estimates of student opinion, right? Because if you get the same amount of responses from a random sampling of each grade, you should get more information that you're looking for, hopefully, than you would in just a simple random sample. So if you just pick 80 kids at random, there's no guarantee that you're going to have 20 from 9th grade, 20 from 10th grade, 20 from 11th, and 20 from 12th. So stratified random sampling is way better in this scenario. So now let's describe how to obtain a sample of, again, 80 students, but now let's use cluster sampling. And let's explain our choice of clusters and why this method might be preferred to simple random sampling. Poor simple random sampling. And one solution to this is if there are 20 columns, right, so 1, 2, 3, etc., each column of seats from the stage to the back of the auditorium could be used as a cluster because it would be relatively easy to hand out surveys to an entire column. You just walk all the way back. So if you labeled the columns 1 through 20, so 1 this way, 2 that way, etc., starting at the left side of the stage, you could generate 2 different integers from 1 to 20. And if you have 2 of them, there's 40 rows going all the way back. So 2 of them, 40 times 2 would be 80. We would get our 80 students. So you would pick 2 of those columns and you would just walk all those surveys all the way back. That might be kind of not actually easy depending on how the seats are right next to each other. That might be difficult in an auditorium, but we'll go with it. And then you'll give those students that survey. And cluster sampling is much more efficient than finding 80 random seats scattered about the auditorium, which would be required by simple random sampling. Another note is that if the grade levels are broken up the way that they are, so for example, the 12th graders are seats 1 to 200, so they're all sitting all the way across to 200, and then 11, 10, and 9, if you walk all the way back, you are guaranteed to still hit a rough estimate of the same size, at least in the different clusters. You'd hit roughly the same number of 9th, 10th, 11th, and 12th graders. So whether you're using stratified random sampling or cluster sampling, depending on how efficient you want it to be and how, I guess, lazy how you're feeling, both are a little bit better, or a lot better, than simple random sampling, depending on what you're looking for. So with all of our surveying methods and our sampling tools and all the things that we know, we'd love to think that the data that we collect is perfect and beautiful and ready to go. But unfortunately, because a lot of the things that we survey have to do with human interests and because of human nature, a lot of things can go wrong. I want to talk about 3 big things that can go wrong and that you should at least keep in mind when you are creating your surveys and sample groups. First is undercoverage. It is what it sounds like. That occurs when some members of the population are either less likely to be chosen or cannot be chosen in a sample. The big one that comes to mind is when you take a census of a city, a state, or a country's population. Now, the census, depending on how you sample and how you survey, is going to miss groups of people. Think about the homeless or incarcerated folks or students living in a dorm. And as long as you account for those things, usually your data is pretty accurate, but it also depends on what you are surveying those people about. And if it's about access to certain things, you gotta be able to account for certain groups, especially with what you're asking for. The second thing that can go wrong is non-response. And that again is what it sounds like. So that occurs when an individual chosen for the sample can't be contacted or refuses to participate. Non-response can lead to bias, especially when the people who have answered the survey answer in one way, but the people who either have not been contacted or refuse to participate in the survey would answer in a very different way. That's obviously going to lead to bias in your sampling. Now, you might be thinking, ooh, politics, non-response. That's a big player in political data. So if you're starting to pay attention to political polling, especially about how certain candidates are looking or the percent of people who would vote for that candidate leading up to the actual election. Now, I personally never believe in those numbers because, I mean, how many people are they actually surveying? How are they getting to them, etc.? I just don't believe any stat on its face. But there's a quote in our book from a polling guru called Nate Silver, and he says, response rates to political polls are dismal. Even polls that make every effort to contact a representative sample of voters now get no more than 10% to complete their surveys, down from about 35% in the 90s. So I don't have a lot of faith in the numbers that they put out, at least before election season, but maybe you do. At least dig deeper into that. But non-response really affects a lot of survey data. And of course, another type of bias, the last thing that I want to talk about that can go wrong, is something called response bias. And that occurs when there is a systematic pattern of inaccurate answers to a survey question. I think you've been a human long enough, you've engaged with other humans most of your life, that response bias should not be all of that shocking. So, the wording of the question, the person asking the question, the person answering the question, how you ask, the tone, the inflection, is it in writing? All of the different things that go into asking these survey questions and how the person responding answers these questions can lead to a tremendous amount of bias. And of course, not everybody is super truthful and everybody interprets questions differently. So if you have a large bit of data or survey data that is raising red flags for you that are like, ooh, these don't feel right, likely you are experiencing response bias, which would hopefully make you go back to the table and rethink how you're surveying, what you're asking, and what you're trying to get out of the people that you are surveying. All right, let's do one last example together, and this one's going to be about response bias in terms of washing your hands. So the problem says, what percent of Americans wash their hands after using the bathroom? It depends on how you collect the data. In a telephone survey of about 1,000 United States adults, 96% said they always wash their hands after using a public restroom. But an observational study of 6,028 adults in public restrooms told a different story. Only 85% of those observed washed their hands after using the restroom. Let's try to explain why the results of the two studies are so different. Personally, I think there are many ways to answer this question, and I'm sure that you could answer this without knowing much about statistics. But let's put it into a nice little paragraph. So, when asked in person, many people may lie about washing their hands because they want to appear to have good hygiene, right? Culturally, that is something that is important to us, at least in this country. So when people are merely observed and not asked directly, right, actions versus words, the percent who actually do wash their hands every time will be smaller and much closer to the truth. All right, that's going to do it for this video. I'm going to go wash my hands and water my plants. Thanks for watching.